All right, first thing I want to emphasize is that this is review. It claims on here that you're graphing functions given to you in this form. You're actually not graphing it from this form, as you'll see. Our question is, how can you describe key attributes of the graph of this by analyzing its equation? And really what you're doing is you're rearranging the equation into one of two forms that you already know. You're taking it from standard form, and you're going to either factor and then use the zero product property to locate the x-intercepts, or you're going to complete the square in order to identify, in order to convert it to HK or vertex form. All right, so here's our first example. We're graphing this this function here, f of x equals x squared plus 2x minus 3, and we're graphing that by factoring. So what we're going to do is we're going to basically set it to 0, because f of x, remember, is basically another word for y, and when y is 0, what do we find? We find our x-intercept or x-intercepts. So what we're going to do is we're going to take this, and normally when I work this out for you, we did it vertically. I'd go below it. Instead, OC has a habit of going across, which I hope that you don't pick up, but it is good to see it. So we have f of x equals x squared plus 2x minus 3, which is what we're starting with. And then we're going to factor it. Well, what does that equal? As long as we have a leading coefficient of 1, we can say we've got x, and we've got numbers here, and then we're either adding or subtracting. Well, we've got a negative 3, means we've got a 1 and a 3 to deal with. What are we going to do? We're going to subtract 1 and add 3, because if we multiply these, we'll get this. And we're going to set this with f of x equaling 0. So what does x have to be for this to equal 0? It has to be 1 or it has to be negative 3, right? So x has to be 1 or negative 3 if we're going to set f of x equal to 0. So the graph of this has two two x-intercepts. Go ahead and see if you can figure that out. 1, 0 and negative 3, 0. All right, so the axis of symmetry, where is that? And we did this before by adding our two intercepts together, 1 plus negative 3, which gives us negative 2, and then dividing that by 2, which gives us negative 1. Or you could just logic your way through it. What is halfway between 1 and negative 3 if we plot it? So that's going to be along negative 1. And then how are we going to find the vertex? Right, we're going to plug negative 1 back into our original equation. So if we plug negative 1 into this, we've got negative 1 squared is 1, plus 2 times negative 1. So 1 minus 2, so negative 1, minus 3. So that's negative 4. So we have the point. Oh, haha. I did the math for you. Okay. Oh, so we have the point negative 1 comma negative 4. So this is our vertex. And now, normally I would just say, all right, take the vertex, take your intercepts, and graph your parabola. But this is a good habit to be in also, is to find yet another point on the graph and reflect it across the axis of symmetry. So we really only have to do math for one more point. If we plug in 2, what do we get out? If we do the math, we'll get 5 out. They've already done that for you. Now think about how many units away from the axis of symmetry is 2. Well, 2 from negative 1, it's 3 units away, right? So now we're going to go 3 units onto the other side of that axis of symmetry. And where does that land us? Negative 4. So the x value is 3 units away. So the reflected point of 2 comma 5 is negative 4 comma 5. And now we've got 5 points that we can use to graph the parabola. So first I'm going to place my axes where I think is appropriate. And then I'm going to plot my x-intercepts. I'm going to plot my vertex. I'm going to plot those other 2 points that I found. And then I'm going to graph my parabola. And then it's got this little reflection here for you. A useful point to consider is that y-intercept. Well, remember when we looked at the standard form, if f of x, if we plug in, well, let's see, if we're looking for the y-intercept, then we need x to be 0, right? So we're looking for f of 0, and let's say that's going to be 0 squared plus 0, so f of 0 is just 3, remember? So at that point in time, so that's our intercept, and then if that's our intercept there at 3, and we mirror it across the axis of symmetry, where's that going to be? It's going to be right there. Oops, wait, I'm looking at the wrong spot. Ha ha ha, negative 3 is our intercept, right? And we reflect it across, there we go. Negative 3 again here. So we've got those 2 points. F of 0 equals c. So f of 0 is going to, in this case, equal negative 3, because that's what c is. And then if we reflect it across, we'll also find the point negative 2, negative 3. And those are those 2 points. And you can just use those to confirm. All right, here's our second example. This time, we're going to complete the square. So we're going to graph this function by completing the square. Why are we doing this? It's review. Because I just threw the quadratic formula at you, and I don't want you to think that that's the only way to solve these. Okay, so we're going to complete the square to write this function. We're going to start by disregarding the constant term. So we're going to ignore that 1 for now, right? We're going to factor negative 3 from the first 2 terms, because that's what I call our greatest common factor. So it's negative 3. All right, so first we're going to factor. We pull negative 3 out. What do we get? X squared minus 2x plus 1. All right, so now that we've factored that negative 3 out, we're going to complete the square only on what's inside the parentheses. So we're going to take half of negative 2, which is negative 1, and we're going to square that. That gives us 1. So what are we going to add to, what are we going to add and subtract? 1. So we'll do that. X squared minus 2x plus 1 minus 1 plus 1. That plus 1 is just being carried down. And now we're going to go ahead and factor just these first 3 terms, because that's the perfect square trinomial we created. So what is the binomial that squared creates this? X minus 1, right? And now I need to copy down my negative 1 and my positive 1. Now I want to take this negative 1 out of these parentheses. So I'm going to multiply it by that negative 3, because that has to be distributed. So I'll have x minus 1 squared plus 3 plus 1. Sorry, I forgot this negative 3. This little guy is still living here. And now we're going to combine the last 2 terms. And what form do we have now? Right, we have vertex or HK form. So we've got our vertex, 1, 4. All right, now we're going to, again, I taught you with vertex form to use just how far, looking at A. If A is negative 3, what are we doing? We're going over 1, down, not 3, or not 1, but negative 3. And if we're going over a second one, we're going down not 3, but 9, right? But now what we're doing is, as a good habit, we're going to go ahead and plot another point. So if the axis of symmetry is at the vertex, right? So that's 1, 4. Let's pick f of 2. Why not? So if we plug in 2, what do we get? We just have to do the math. There we go. F of 2 equals 1. So we have the point 2, 1 on the graph. And we can reflect that point across the axis of symmetry. We don't need to do the math again. We're going to get 0, 1. Because that's the other side of our axis of symmetry. So once I plot it here, it'll make more sense. So I'll draw my graph. I'm going to start by plotting my vertex. There's my vertex. And then the point that I plugged in, I found was this point. Well, when it reflects across the axis, there's my other point. And then I can neatly draw my parabola. Now, because A equals negative 3, what we're going to do is we're going to go back and we're just going to think about, from that original equation, that standard form, knowing that A is negative 3, what do we expect to see on this graph? We expect to see it being a vertical stretch, and it is stretched. We expect to see, we expected to see it reflected across the x-axis because it's a negative value of a, and so which means that we know that it should open down. Does the graph that we drew match this? So this is a good check to do. And yeah, it matches all those characteristics. So that makes it likely that we plotted our graph properly. You can also use that y-intercept, remember, because that's c. That's another way to check. Okay, so this is what I left you to do for homework, is to finish the reflection, and then oops, no, not going to give you that. Finish that page on your own the best that you can. You're going to pause and look at that, aren't you? And then I said, don't bother doing this yet. We might come back to this, but don't bother doing this part. And then for the homework, all you need to do is finish that reflection, finish that page of the reflection, and then do numbers 1 through 4 on the practice. See you in class.